All right, well, welcome everybody, and thanks for joining us for the first ever ATG Universal User Group, Charity Hospital New Orleans Scan Project Highlight. So thanks also to any Revit and BIM user groups that are joining us today. You guys are the ones that tend to be the loudest voices in your local AEC communities regarding new technologies and best practices, and we absolutely love to be part of that. Our goal with this Universal User Group is to bring all user groups together around a topic that is trending across many areas in the AEC space. We think it will benefit everybody to hear questions and concerns from peers around the country live. So this is new to us. We're testing it out, so we're glad that you're here. And I also want to send a special thanks to BNIM in Kansas City, Missouri, and Williams Architects in New Orleans for inviting ATG to be part of the Charity Hospital team. But before we jump in, let's just do a quick introduction of some of the voices you'll hear on our end today. So Jeff?
You got a slide.
Hello, this is Jeff Landers. I'm the lead scan technician here at ATG. And me and my team are the ones that did the scanning of the Charity Hospital.
And I'm James Hughes. You can see me on screen there in the middle. I'm just a humble architect here in Central Arkansas, but have exposure to both performing scans with Jeff on Jeff's team, as well as downstream of that, working with the scans inside of Revit, both modifying existing models to match a scan and also starting models from scratch for a laser scan. So just kind of, my knowledge is an inch deep, but spans all of the sides of this.
And I'm Mandy Breckenridge. I'm also a licensed architect like James, and I've been part of ATG's technical staff for a couple years now. I'm mostly involved in our team augmentation group. And if you haven't heard about ATG's team augmentation, it's simply a contracted service where we provide some of our staff to plug into your projects. So we really do a lot of everything, including modeling from laser scans. The scanning side of ATG services is really interesting, and I hope you find it interesting today too. So today, Jeff will be leading most of our discussion around scanning prep and implementation, and James and I will speak more with an architect's perspective from the Revit point cloud usage side.
Sure.
And one thing to keep in mind today as we go forward, that this is not a webinar. We definitely do not expect or want this to be an hour-long one-way discussion. It's a little bit difficult with this many people, but the best way to make sure you get the information you want to know is to participate and to ask questions. And so in a normal user group, there's generally a small group around a table, and speaking up makes sense. But with a group this size, we're going to be relying on Zoom's chat window. So our hope is that you ask questions as we go. We don't want to wait till the end and have 100 questions over a lot of things. And we will definitely rabbit trail to whatever you want to hear about. So type in your questions ahead of time, type them in as we go, and we'll answer them. And if for some reason we have way more questions coming in than time allows, we're going to send out an email at the end of today or very briefly this week that sort of answers everyone's questions in mass. All right. So please, please, please don't be shy. Let's be conversational about this. We'll do the best we can on our end too. Back one. All right, James, so give us a short overview of why we're here today.
Well, we're primarily here to show a very large scale laser scan project that we've been able to be involved in. But I wanted to kind of make this clear that laser scanning as a process and as a technology that designers should be leveraging and utilizing is scalable even to the smallest project. We've actually we started with complicated mechanical rooms. You know, that someone would open up a room that just had hundreds of pieces of ductwork and piping, and they were wondering if there was any way to make sense of that. And that's kind of some of our first projects. And through learning lessons and kind of growing our squad and our technical capabilities and how much equipment we have, we were able to participate most recently in the Charity Hospital scan and scans of that large of a size. So this is something that should be looked at even for small scale projects. The Charity project, you guys are probably going to be sort of impressed with the scale of this, at least as a scan job. It's a million square feet, near as we can tell. Now we'll know exactly how many square feet it is after we finish modeling this dude, which is going to take a little bit. but it's a giant amount of data. And so if any of you guys have experience laser scanning, we'll talk more about this later, there's a challenge with generating too much data. Even though the data per point is fairly light, it's just XYZ coordinates for a point, these scanners are just harvesting millions of points. And when you put it all together, I think I had calculated with the number of hours that we put into this project and the number of scans and the points per second, we're estimating that what you guys are going to see inside of Revit is going to be close to 632 billion points that Jeff's computer is going to try to manipulate, and we'll see how that goes. And then you're going to see maybe you could call it a dumbed down version or a unified version inside of Revit, hopefully here at the tail end of this. So it's a really large project. It has challenges with not having lighting inside of it. And so that, we've got to kind of have our own strategy in the planning phase of this. And we'll talk more about with Jeff about how he planned for this, how we figured out which scanners to use, how many people to get the job done in the time that we had. And then planning ahead for how we can chop up a model so that it can be used inside of Revit. This is a 20-story project. And so, one of the ways that Jeff has carved the model up is we wanted to have a point cloud per floor. And inside of Revit, in the visibility graphics, we got the ability to control which scan is being lifted by Revit so we don't bog it down.
Yeah, we definitely don't want to dump this entire building as one giant scan file into the Revit program. There's no computer that I know of that can really handle that.
If you had a BIM box, maybe.
Maybe if you had a BIM box, a really nice BIM box, but for the average Revit user, it's just unattainable. So we had to keep that in mind. We didn't want to hand this over to the architects who hired us, and then they couldn't physically manipulate the model and use it at all. So that was part of our process here that we'll talk about a little bit more. So the building itself, Jeff, you actually went here. You were involved with almost all. Is
that Jeff in the old photo?
I think
there?
so.
Or there?
Yeah, he physically built the building. Tell us a little bit about the building before we get too far into the programs.
Of course, you know the name. It's the Charity Hospital building in New Orleans. It was built in the 30s. As you can see in the picture in the upper part of the screen, that it is a steel structure encapsulated with masonry. The building, like James said earlier, is almost 1 million square feet. And when I walked up to it the first time I looked up, I said, oh, I don't know if I can do this.
Yeah. You brought lots of people with you, but you still weren't sure.
Right, yeah. And so when I toured the building before we actually started scanning, the questions were asked, like, are any of the stairwells that run all the way to the top of the building, or is there a stairwell that runs to most of them?
Yeah, let me pause you right. We've got a question already in the chat. Someone's curious about how you tackle multi-story building. I think you're probably about to talk about tying the scans together.
Right. So yeah, that was all part of the planning. We want the data as small as we can for use in design. And so we found that stairwell 6 ran from the basement level all the way up to the 18th floor.
And that was the only thing that actually connected all the floors.
That actually connected all the floors minus the 19th and 20th floor.
Right.
And so we found the backbone of our scan there. So that became the first scanning project when we were actually scanning. And then all the floors were scanned separately. And then all of them were geo-located using the stairwell 6. So everything had its own home scan. And that's how we were able to put all 21 floors actually of the building together.
So what exactly is this building going to be used for? Did you get any of that knowledge while you were on site? You talked to anybody?
Yeah, from what everybody was talking about, that it is going to be residential and with some government offices in it. LSU and Tulane, I believe, are going to be using part of the building. And it's also going to have retail spaces and restaurants downstairs.
We've got a question from Corey. What was the time frame to complete the laser scanning and then inputting all that information into a working Revit model? We're still working on the last part. I can answer that. But how long was it to get this thing scanned with a crew?
Right. It took myself and 4 technicians 4 weeks and 2 days to scan the building. And then it was another 6 days of processing and getting it all ready to go into the design software.
Jeff, if it was just you and a tape measure and a bunch of stack of floor plans, how long?
just me and a stack
to
of
get
photos.
to get the 632 billion measure points.
If somebody asked me to do that, James, I would quit. It'd take too
Sure.
long.
Yeah. So we could have ramped that up more too. I mean, we could have had more people on site, more equipment, but with what was the equipment loadout? Like how many people did you have?
So there were 4 people working approximately 10 hours a day, averaging 10 hours a day, running the Leica BLK 360.
Mm-hmm.
Each person was turning in approximately 250 scans to me each day, which, 900 to 1100 a day is what we're trying to process.
Mm-hmm.
And it was all I could do with my computer to keep up with the guys scanning.
Sure.
They would scan 10 hours and I'd process probably 12 hours a day.
Well, before we let you give us a tour of the model, I just want to answer the last point that you see on screen, why laser scanning? Because there are a lot of architects who are thinking of, well, when I get a big, juicy historical project, that's when I'll look at laser scanning. Or if it's just a really large commercial project that has some existing conditions. But just wanted to draw it back down to that other fine point of, I would be looking at laser scanning with actually every job, because the alternative to that, the best practice workflow that you have other than laser scanning, the next best will be drone, which gives you some level of accuracy with photogrammetry. But if you don't do that, then that joke I was making with Jeff actually is true. I mean, you're looking at sending a couple of people, one holds a clipboard and the other a tape measure, or maybe if you're nice to them, you go to Lowe's and buy a $20 quote unquote laser scan. And then that way you can actually take a bunch of contiguous measurements, but you end up asking those intern architects or whoever you send out to make sure that they take a few hundred pictures, because you're gonna have to count bricks and blocks and ceiling tiles and basically guess. The alternative is pretty grim at documenting existing conditions. So just want to make that point before we moved into it.
And something about this building in particular, since it's so old, we can actually see in the laser scans where the building has settled in some places over time. We can literally see the floor slab sagging in a couple spots. And in this particular project, the design architect is 2 states away, so they can't just hop over on an afternoon and recheck a condition. But when you have a point cloud and you have Autodesk ReCAP, it allows you to do some 360-degree photos inside of there. You really have this absolutely full amount of data that you can reference for any and everything as you begin to start your renovation process and your demo documents across a project.
Yeah, what you guys are looking at here, if this is your first time looking at a point cloud scan, it looks kind of like, and this is how I characterize it, it looks like an explosion happened just a quarter of a second before this. And the more you zoom in, you'll start to see particles. And if you get real close, they start to seem to separate a bit. And then you're able to make out a surface from a plane of these particles. But each one is a entirely defined XYZ point. It is a snappable object within Revit, which is very critical. And if it's been years since you looked at a point cloud, the last one you looked at may have been black and white. This one actually pairs together globe photography or a full panoramic photography. And it looks at the RGB value of the color of the pixel and assigns it to that point, so that what you end up with is a point cloud that actually has color and lighting like it actually captured while it was there. We got a question in from the chat. Did you have to sell the architect on laser scanning? And if so, did you use other metrics other than the shortened timeline to gather existing conditions? I guess another way of saying that, was the customer's hair on fire? Is that how we got the job?
The reality here is the architectural firm that Mandy mentioned from Kansas City had actually used point cloud before.
Mm-hmm.
Our name came up in the pool. We threw our hat in the ring and didn't get the lowest price, but after showing them the workflows, they liked what we were doing and they hired us to go do it.
They like Jeff, that's why.
No, they didn't like Jeff, they liked the workflow.
Right.
Another question, did you use 4 similar scanners, or were there a mix of higher, lesser quality types used? What was the strategy for scanner selection?
We're going to get more into the strategy later. I think we can maybe pause that one because we're going to talk about scanners and the loadout. Do you want to field it now?
We can go ahead and do that.
Sure.
If you want to go ahead and fill it over, go over to the slide with the scanners on. On this particular project, it was planned using the Leica P40 scanner. She'll have the ranges up there in just a second of it. The workhorse on the project was the Leica BLK 360. I want to explain a point cloud that's very heavy in data. And so that particular scanner gives us the opportunity to turn it down to a point where we collect enough points in a room, but not so many that we fog the scan down or the data gets too heavy and can't be used. And then the Leica RTC 360 was fairly new in the arena. So Leica came out with their RTC 360 and we were able to put it through the ringer on this project. And we used it to do the exterior of the building. Actually worked out pretty good for that.
Yeah, and so you had mentioned that especially for some of the smaller rooms, you were able to put everything on pretty much a low setting to capture the scans.
Yeah, and that was on the BLK. We put it on the low setting, was able to go in where you would normally pull 500 megs of information in a single scan. This is about 210 megs on the low setting, but still gave us enough points in a small room that you could see what you needed to see.
Right, which helps also this file size for dealing with it a little bit later. Yeah.
And I'll talk about file size. We collected 7.3 terabytes of data on this in between collection and what we needed to do to build the model. Mm-hmm. And in the end, that was all brought down to 268 gigs. And then once broke down for use in Revit, the largest scan file that needs to be used is 26 gigs.
Did the laser scan pick up the MEP systems? I guess there weren't any. This thing's been gutted, right?
Well, all exposed MEP was picked up. The 20th floor was actually a mechanical room. And we did 100 scans throughout that mechanical room to pick all that data up. Mm-hmm. There's also a very large mechanical room on the first floor that is actually 3 stories high, no, 2 stories high, excuse me, and probably 20,000 square feet. And we scanned in and out of all the piping and had to pick it up.
Yeah, and that we've got a surveyor kind of answering, this isn't just vertical construction, but you could use that Leica P40 if you wanted to do very accurate surveys of topography. And so, you got an ability to scan very tall buildings if you want to use that for vertical construction, or you might set up targets if you've got a real big outdoor space. Did you want to give us a little bit more of a tour of the building? That's kind of where we picked up or left off rather.
The first one I'm going to show. This is the exterior of the building itself. This is a combination of 116 different scans around and on top of the building. We actually use drone technology to capture most of the roof area. In reality, when I walked up to this building for the first time, this is where I was standing looking up at it. We'll just pop
There's a slight lag, Jeff, just so you know, just from the Zoom meeting, but it'll catch up in a minute.
I'm trying to look at your screen and mine at the same time.
That was very generous, a slight lag.
It's a few seconds.
Okay, it jumped into photography mode now, so we're not looking at the point cloud right now.
Sorry that it's a little jumpy, but there is a lag. And this is where I was standing when I looked up and made the comment, oh my gosh. Because I'd studied it, Googled it, looked at it from anywhere I could possibly see it. Mm-hmm. And until I walked in up to this building, I didn't realize how big this thing was.
And so we're looking at this in Autodesk ReCAP. Notice the map in the top right corner. This is kind of your directional. You can see all those little points are showing all of the exterior scan locations that Jeff took. So this particular file that he has open has nothing really on the interior, maybe just a couple, but it's really mostly the exterior file itself.
So Jeff, if I'm an architect and I haven't dealt with the point cloud before, what do I use ReCAP first for before I get it to Revit?
Well, as an architect, you're basically going to use it for the visuals. Mm-hmm. So it has panoramic photos with each scan location. Mm-hmm. And that's represented by these dots and these little spheres that you see around here. And so you could actually, and I want to give it a shot here. I'm going to jump from one to another. Let's just jump out to the street right here.
So you can click on the map or you can click on those globes.
I didn't expect that. That's me and the Leica guy outside.
Smoking on the job.
But is. And we can take it as soon as everybody sees the top of the building, I will switch it to another one.
Right there.
Okay. And then here's another one. We can jump out to the front. Excuse me.
So you can take measurements from this, but really you ought to be taking measurements once you get into Revit. But early on, before you've done any Revit modeling, if you just want to verify just how tall this thing is, you could snap measurements from it.
You could get approximate measurements on it by doing that. You can see it captures more than just the building. It captures all the surrounding area.
Right. It's throwing out a sphere of points, right?
Right.
Yeah.
Yeah. So even if I open up this map here, you can kind of see what all is in the scan around the city and everything and around the building.
Mm-hmm.
And then last one, we'll go take a look at a view from on top of the building.
So inside ReCAP, you could actually crop out those points if you didn't care about across the street and just wanted to lighten the load on your computer.
And what I usually do with those points, James, is once I get it ready to go into design software, namely Revit, I'll go out and I'll cut everything away from the building away.
Mm-hmm.
I'll create that as another unified project that can be turned off and on in case they wanted a vicinity map or something.
Yeah.
Their project.
So you're not throwing it away.
You're
just
throwing it away.
putting it on a layer, to use an AutoCAD term, that they can turn off.
Turn off or on inside of it. Then that's what.
So how do you, I know that the old scanning technique of registering scans, you used to have to like level tripods for a few minutes before you took a scan and work within the software. If you've got a crew of 4 people bringing you iPads full of scans, how does ReCAP help you with that?
Well, for one thing, with the BLK to begin with, it doesn't have to be leveled. It levels itself, kind of like your cell phone does.
Okay.
You know? And so we didn't have to level that. One thing we do want is a control.
I knew the answer to that one. I feel like an infomercial guy at some points. I knew it leveled itself.
Now, on a project this size, we did want a control scan that was level so that we could work from it. And again, that was the 000 in the basement of the first scan. And it was a leveled scan done with the RTC 360.
Mm-hmm.
That is the scan each one of these floors are tied back to get position.
Okay.
So, home. The next one that I'm going to show is all of the scans put together, prep for Revit itself.
This is where you need a BIM box.
This, well, yeah, or you're going to need a supercomputer of some kind.
Yeah.
So this is a combination of all of the unified floor scans. So each one of these were a project in itself, and then it was unified, tied back to that home scan in the basement, and then stacked on top of each other right here. And so this actually has everything we need. Here's the exterior, and I also have it set up to where I can turn off the extended, and this, what I was talking about earlier, James, is just around the building. This, how's the lag on that, everybody?
It's good. We're
It's all right.
just a couple seconds.
And this, we can take a quick spin. This works
For
a lot.
billions of points, it's great.
It's moving really fast. We're going real fast on mine.
Yeah.
And so we took a turn around the outside of the building there, showing you that. I can go ahead and turn the exterior off. Now I'll turn the basement off. That is the notorious stairwell 6 right there. And that's what we tied the whole building together.
And Jeff has split these up in anticipation of how the architects will want to split it up and start modeling in Revit too. So he could have grouped these in any way that he felt necessary.
Another thing I want to throw in, Mandy, at this point, if it did need to be broke down a little bit further, with this model, I can go in, like you were talking about, maybe cutting up the floor levels a little bit on the lower levels.
Yeah, like an east wing, west wing thing.
Right. We can break it up even more, and that'll become regions in this. And when it goes into Revit, you'll be able to turn those pieces on.
Yeah,
and off.
and the only reason that would be beneficial is if your computer is struggling to have that much point data open in Revit at once. If you needed to sort of dissect it a little further to be able to only work on certain areas at a time,
Yep.
which we're anticipating with a file this size, we needed at least some level of breakup just
Right.
because it's so huge.
So I can go, so basically the largest floor is the first floor, and there it is filling in on the screen. But by the time you get to the 20th floor, it is a whole lot smaller, sitting up there on top of the building. That's actually a combination of 20 and 19. There's a basketball, half-court basketball court right there.
You mentioned also to keep this file size lighter. You don't actually have the photographs inside of this file. Is that correct?
Now, this particular model was created from all of the ones that do have the photos in.
Mm-hmm.
And in that process, it's called usually unification of the points.
Mm-hmm.
It removes the picture data, retains the colors on the points from the pictures, and then you lose all of that heavy data that you don't have to deal with, and Revit can't use it anyway.
Is it getting rid of some redundancy in the points?
Not in this, not the way I do this.
Okay.
You do not. Now, any 2 points that hit the same place stay in the unified. There is a way to bring it down even further, but it's harder to use in a design software.
And for our particular project, we wanted to retain some of that photographic data.
Right.
And so Jeff had those still in the individual floors. We can open up each floor individually in ReCAP at the same time as we're modeling and check out the 360-degree photos. They're just not technically.
And we're going to show floor 12 here in a minute. We'll be able to pop into those. So I believe we're done here. This is basically how we put it together. I'm just going to go through. We started at the top and worked down through the floors, and you can just watch them populate as I go down through it.
Now, are you, how is the registration of this? Is the software registering itself, or are you manually doing any of this? I mean, how much human error do you have in this?
Well, basically the registration starts in the field with the ReCAP Pro app as they're going through the building. That is a great thing because as they're walking through, they're looking at a screen on an iPad, and it's actually creating a roadmap for them, let them know where they've been and where they need to go. And so they can just step through, and it pre-registers inside of that. If they make a mistake, they can fix it in the field. Most of the time I tell them just to move on and create a new group. We'll get it on the computer. Most of it's already done. And then we take those created groups, make any corrections that needed on 1 or 2 scans that are wrong, and then combine those groups together.
Okay.
Inside of the ReCAP program.
Right. So it's not normally you looking for targets and lining up several points to manually register it. The software now is handling part of that lift.
Yes, it's doing part of that. Yet you still run into every once in a while, for some reason, it just won't do it. And so it is a manual point to point by target. But what I mean by target can be the corner of a wall. It can be a light switch cover. It can be anything that you can see in 2 adjoining scans that you can click on and bring those together. Mainly, you want to click on 2 surfaces on a single point so to bring it together. Yeah, it's still not like the old days where we were lining it up point to point.
So you're bringing it in ReCAP, and you are breaking out each floor as a separate project and then unifying that together. Okay.
And all of these floors were tied back to several copies of Stairwell 6 so that as I brought them into this point cloud here, they knew where to stack up on top of each other.
Okay. That's better than you manually stacking them where you think they ought to go.
Right. And a whole lot more accurate.
Sure.
So that's the whole interior of the building. There are over 4,500 individual spaces inside of this building. The average is 2 scans per space. When we got into mechanical areas, we had that almost triples, if not quadruples, in those areas to get the detail. We collected over 14,000 scans on this project. It's cleaned up to the 9753 you see on the slide. And that's the story of bringing that baby together.
We've got a question from our chat, and we may not actually. We should probably kick this one to the field because we're in full disclosure here. We are like a distributor, And so, obviously most of our exposure / preference is tied with Leica. We made that choice a few years ago. But there's a question about, comparing a Faro scanner with Leica scanners. And I'm going to just kind of open it up to anybody that has experience with that in the chat. If you just wanted to kind of list that. Jeff, you can give your own biased answer on this
Biased
one.
opinion.
That's right.
Yeah. It's not so much the scanner people, it's the registry software is what the big deal is.
Mm-hmm.
I've used the Faro scans and combined them with Leica scans, and it's fine. I do prefer the performance of the Leica scanners. They're faster, especially the RTC and the BLK. So
we have a request to speak louder, Jeff.
okay.
I'll move the mic closer to you
All right.
now.
Can everybody hear me now?
Yes.
Okay.
All right. So one more question before you move on to the next piece. If each floor was treated individually, how are you accurately tying them together in a final ReCAP project file? I think I know the answer to that. It has to do with the stairwell.
Mm-hmm.
And then common scan targets you can see from each floor every time. That was their supposition. So you're not using scan targets. The software is automatically linking that, isn't it? If it has enough overlap?
In a way. So each floor, like I said before, is a project in itself. And with the ReCAP Pro software, I can take 2 projects and load them into one and bring them together. So on each one of these levels, I brought in a copy of Stairwell 6.
Mm-hmm.
There is a number on each floor at the door that tells me what floor it's on. It's handy. And when we were planning this in the field, the first scan of every floor was done in the doorway of Stairwell 6 on that particular floor.
Mm-hmm.
And so when I'd open those 2 up, I got scan 1 on the floor. I know where it's at. And then all I had to do with just a little bit of math is figure out which floor correlated with which scan number. And at that point, I just took those 2 scans. And I'm going to say 90% of the time when I chose those 2 to look at each other, it automatically put it together. And floor 18 and 7, I believe it was, are the 2 that I had to manually bring together.
So when you scan in the doorway, half of the scan's looking outside of the floor and the other half's looking inside of the stairwell. And so you've got maybe not 50% overlap, but you've got a lot, enough that where ReCAP can look and sort of automatically figure out which 2 points are the same point between 2 scans.
So when I was doing that, the hallways are small, so the scans were getting 40 to sometimes even 50% overlap on those 2. So it worked out real well.
So we got another question. Could you have done this targetless, but you didn't actually use field targets?
I didn't use a target in the entire
You just
building.
picked crisp points like corners of something or the
Right.
screw on a light switch cover or something like that.
Right, and planes.
Mm-hmm. Cool.
So we're finished in here. Do you guys want to go on to floor 12?
Sure,
Or do
absolutely.
you want to show them something else in here, Mandy?
We can always jump back if something comes up.
If something comes up. All right.
So what is it about floor 12 you're going to be showing us?
Yeah. So floor 12 is an interesting floor because if you look at the rounded areas on these 2 corners here, there's actually a elevated auditorium teaching area for surgery and autopsy.
Okay. Why is it so dark and kind of scary there?
Yeah, it is dark and kind of scary. Yes. So there's floor 12. And basically, I was wanting to show this piece mainly to get you familiar with floor 12 and also to give James an opportunity to jump into Revit and look at this floor and how it looks inside of the design software. So we're going to take a small little tour down a hallway over here.
Yeah, right now, just in the point cloud itself, he could click between photographs, or he could, click on that kind of map that's sometimes up in the top corner. But we're just navigating by zooming in and looking at the points.
And it's just a couple seconds behind you.
Only a couple seconds, okay. So here's the inside of the building. There wasn't much light except what was coming through the windows. And so we actually had bought some battery operated lights and we were placing them underneath the scanner as we went through. And that gives us the light. if there is a no light situation, there are settings that we can go in, and this would, if we
Guessing the
had,
flash is not good enough, that
right,
would be okay.
if it's not good enough.
Okay.
So this isn't great, and this reminds anybody that's been doing scanning for a very long time, this is kind of what it looked like inside of a scan in the days when they were just black and white. This has a little bit better quality, but so what basically demonstrating, if there was no light in this area, we still could scan it and you would still be able to use it in your design software. It's just going to be in the black and white gray tones.
It's actually creepier.
It is a pretty creepy place. So I thought I switched back over. So we're going to go down into the little, down the hall into the little auditorium that's
Did you
down here.
use a halo lens is the question we got.
A halo lens.
That's a no.
That's a
He
no.
doesn't know what that is.
So as we look around, we can just go from point to point. I've lost my directions. So
This is what I love about ReCAP is getting these 360-degree images. It's just critical in a building this size to re-verify what is where.
Yep.
Hey, I made a mistake, folks. I just took you to the wrong corner of the world.
So we're flying again. Is that what you're saying?
No, I took them to the wrong room on the wrong end of the wing. Hey, we're
There you
doing
go.
it. We're doing this live. What could go wrong? So here's the rooms that I'm talking about. Now that is a creepy picture. This is actually where they did teaching surgeries, and also the one on the other end was for autopsy.
I love that it's covered in subway tile,
Yeah,
It's
they have-
cleanable. It's
it's
cleanable.
very
James.
cleanable.
right?
So here's this room. This is the actual photos laid on top of the point cloud. If I click this, this is the actual point cloud. It kind of makes it translucent. We'll go down to the bottom again.
So if you're just measuring just this room using a tape measure, if that's all you've been asked to do, we're going to remodel this room. If you're not laser scanning, I mean, just for those of you joining us, if you haven't used a laser scan, imagine what you're being asked to do, even with just a simple curved wall, with just one curved wall. That's going to be tough.
You can get
Right.
it close, but
You
it's
can
not
get
going to
it
be
close.
accurate.
Just take a lot of pictures.
You take a lot of pictures, and
We'll
you're going to have
assume
to.
that there's 4 foot, 4'6" between those walls and make some assumptions.
Right.
Assumptions that it's a consistent arc, right?
Yeah.
Yeah.
Do we have, so what about line of sight? We haven't brought that up yet. You know, laser scanning, you have to see everything or else it's going to be completely in shadow or darkness with no points.
Or with no points, exactly. So every scanner, no matter who makes it or what model it is, can't see through walls. So you want to be able to place the scanner in different areas where it can pick up as much of the data as you can.
Maybe up high.
Yeah, high is your friend.
Yeah.
Shooting down in there. And there was a question about mechanical stuff earlier. You can see the sprinkler system
Yeah.
up above.
If it's in the room, it picks it up.
If it's
basically.
there, you can see it. There's the light fixture, more sprinkler system.
So not in charity, but in other applications, can you get above the ceiling? I mean, if you're wanting that plenum space, that interstitial space, you know,
Yeah.
is that a possibility or is it just
We've
way
developed,
too much labor?
we've developed a workflow that, yes, it costs more. It is more, it takes a whole lot more time,
Yeah.
but we actually have tripods that are fitted where we can lift the scanner up to 10'6".
Mm.
That would work in most places with a lay-in ceiling. We just pull a couple of tiles out, scan just below the ceiling and then just above the ceiling, and we can tie those scans with the room below.
Well, that's the same strategy as scanning in the doorway of the stairwell.
Yes,
Yeah.
exactly. You're trying to maintain that 40% overlap.
I love that they have the pull bars to be able to pull yourself up.
Yeah,
That's a very interesting space.
right. It is very interesting. I'm going to go to this location, James. I'm going to turn it around and look back into the room.
Okay.
And I'm going to go to point cloud. And at this point, I'd love you to show them the same area inside of Revit.
Okay. Well, give me just a second here and I will Shanghai the screen.
There was a question, why was this building abandoned? Oh, that was private to me. So it was actually abandoned after Hurricane Katrina.
Yes.
They basically evacuated, and to my knowledge, they did not go back after Hurricane Katrina. There was enough damage that they just left the building.
They closed Katrina plus 3 days.
Here I am in every architect's friend, the friendly, warm, welcoming embrace of Revit. So we've got a plan that's only just begun on the modeling side. We hope to be able to come back and show you guys what we've been able to accomplish with modeling on top of this.
We will come back.
We will, yeah. And so we've got a plan where this has already been brought in. So if you're in Revit, just to kind of glance at that workflow, I'm not going to click through it because obviously we've already linked in. But if you just go to Insert, you'll notice that you've got a dedicated command just for inserting point clouds. And it's as simple as linking a Revit model. You bring it in, and you may have to adjust your elevation so that you set the bottom of the finished floor to what you have marked as a 0 level inside of Revit. And with just very minor tweaks, you're ready to rock and roll. And so really the trick inside of Revit becomes controlling your visibility, because if you look at everything, the point cloud can be a bit confusing. If you limit how much you see, then it can actually be very beneficial. And so the current view that I have is not actually how I would operate day to day if I'm modeling walls, for instance. You know, by default, Revit has a cut plane that it sets at 4 feet above the finished floor. And what I like to do whenever I am creating a new plan is to limit that slice of the point cloud to, in some cases, just an inch, maybe just 1 foot. And so I'll set the bottom of my view range to be either 3 feet or 3'11". And that way I'm looking at a very crisp delineation of where the points are to be able to create objects to that. Now, really, we were just going to look at what we've got going on the floor. Now, this floor appears to go down and down, so I may not actually be looking at the bottom of it here, or actually it's slicing through it, isn't it?
Mm-hmm.
So I can adjust my view range inside of Revit to see more or less of this. I could do a plan region if I just wanted this room to jump way up and way down, just like you would with clear story windows. But real quick, let me just jump over to my view range, and we'll just make an adjustment and see if I can help this out. I'm doing this live, so I actually don't know. So right now we're 4 feet above is where it's slicing, and we're looking down to exactly level 12. We can adjust up our cut plane, and we can adjust down the bottom of our scan, and that will allow us to slice higher and look lower both at the same time. To be able to do that, I do have to adjust my view depth because the bottom can't be below the view depth. How far down below that floor does it travel, or is the floor of the surgery, that actually is at the floor level?
That is at the floor level.
So we just need to go higher then. So I'll leave these bottom 2 values alone, and we'll raise up our top. We'll bring us up, I don't know, 9 feet, and we'll make our cut. We can make it also at 9. Maybe that's too high. We'll see. We'll hit apply. Now we're up higher. And yeah, I can see down lower. I can see some of these stairs here. If I had been a smart man, I would have figured out what heights I need to take a look at, but I'm going to play with this for just a minute. If it's boring, we'll move on. But I'll bring it up just a little bit higher. Got to change this one too, 10 feet.
I do like that Revit retains the color of the points. You know, the points read the photographs and sort of, I guess, change the color of the points sort of, and Revit still sort of retains that materiality.
So this must be like a double height space then, because I've actually sliced through the ceiling here now, but I'm still not high enough.
Right.
Yeah, it's pretty tall.
Okay,
Yeah,
let me
it's pretty tall. It
be a
goes
little
all
more
the way up
generous here. We'll go up 15.
I would suggest raising the bottom of
Now
that.
we're getting somewhere.
Yeah, or just stick a section in.
Yeah, thank you.
You're welcome.
All right, so we'll go to view, section. I get a warning because I don't have my new computer set up yet. We'll see if mine allows me to do this with my memory. I don't know what all point clouds have been turned on in this particular view right now.
We will see. I do have a question coming in. How is linking in the point cloud affecting the file size and file performance? And so that's exactly the reason why we split the point cloud up into floors. So James is able to just have the 12th floor on here as he's working on the 12th floor. We don't have every other floor of the point cloud turned on that we don't need at this particular point.
And it's linked, so it isn't increasing the size of the model. Now, I limited the depth of that section probably to about 2 feet or so. See if I can count up here. Hey, we're at the top.
There it is.
And I can limit it more and get more of a crisp line. Right now, we're seeing an arced radius. That's why it's showing as a smattering of dots there. But I can actually get real tight with the section depth here. If I zoom in a bit, probably should have cut it perpendicular to the steps. Whoa. So I'll bring this in a little bit tighter, and in real time, Revit will show me a crisper delineation. This is kind of the trick to making sure that you get accurate with placement. You know, if I care about what is the slope of this tiled floor here, if I limit this, I can get in there and figure out exactly if it is, you know, 1/4 and 12 or what the pitch of that floor is to be able to correct it. There's lots of cases where it wouldn't occur to you that there actually is a slope to things. Like you've got a floor that's settling. You've got, in this case, not in this particular view, but there are window sills that are sloping. And if you're just going around taking orthogonal measurements, it may not even occur to you that there are things happening that aren't square, that there are things that are, you know, at an angle, or in this case, so we've got radiuses that we're dealing with here.
Can you show us your visibility graphics?
Yeah, sure. All right, so if I have modeled a bunch of things and I want to now not see the point cloud, or maybe I'll duplicate this view and make one that doesn't have the point cloud. If I just go to VG for visibility graphics or VV, Revit is intelligent in that if you add complications to a project, if you add AutoCAD files, if you add Revit links, or in this case, point clouds, Revit will add on the end of this another tab to control visibility related to that thing. So here on the end, we have a new tab for point clouds. And check this out. I've actually, well, I've got a view template that's been automatically assigned, I bet you. So let me unassign that. So we'll go to none. Then I'll come right back and it won't be grayed out, I hope. Right, so now I can make changes. This is why it's going slowly. I got all the floors turned on. I should have turned off everything but the 12th floor.
And this is what Jeff had set up ahead of time in ReCAP, basically. So Revit is reading, correct me if I'm wrong, Jeff, Revit is actually reading those project files that you had set up in ReCAP, how you broke it up in ReCAP, and in Revit you can retain that information and turn things off and on individually.
And what I'll point out, if anybody saw the memory warning that James was getting with going in here and turning those scans he didn't need for this view, it will let Revit work a lot smoother, a lot faster, so your latency issues go away. And so now he is doing that particular area. Another thing, once you get finished showing this, James,
oddly enough, I've still got other four. Oh, we've linked in another model. We've got two models linked together.
Turn the link on.
Yeah. It's a little more complicated than we're letting on here.
And just to clarify, this is being recorded. There's a couple questions about that. And so the recording will be available to anyone joining us today and can be available to anyone that wasn't able to join today.
Yeah, so we had a core and a shell model, and the point cloud is integrated into both. And so I had turned off the visibility in my current project, but the linked in project, it was still bringing that link through. Again, it is a link, so it didn't make it a super heavy project. It just made sure that it was turned on. All right, so when I'm working in an area in Revit, and we're not, this isn't a presentation that kind of gets too much into that, but basically my workflow is to have a section that goes longitudinally and one that goes transverse that are limited to the depth of the slice that I want to look at. And that way I can take any Z measurement from either direction, and then I'll have a 3D view open on a second monitor, and primarily I work in plan. Until I need to set the elevation of something. So, you know, when you're placing walls here, we're not working orthogonally. We didn't just make these 90 degrees. In fact, they're not 90 degrees to each other. I drew a reference plane from one exact corner and then zoomed way out to the far end of the building and set the reference plane on the exact crisp corner where that occurred. And that way the decimal degree that it happens to be off of square, which it is exactly captured and modeled correctly. I think that's probably about as far as I'm going to go in Revit. We're already working on some walls and some stairs here.
One more thing I'd like you to show them is using your camera view and your three views. Is if you're in the space and you want to quickly kind of just look around, you can always snap a picture in there inside Revit. And I'd like you to show them what that looks like. It helps you to understand the space when they get complicated.
Yeah, so in your quick access toolbar, next to your default 3D views, one for camera,
Anybody that's set up interior shots knows about this, but you just click here to place, drag it out. Now, I don't know if it's going to automatically assign a view template that turns off
The point
the
cloud.
point cloud, but we'll see. And we can turn,
Turn
it
it
back on
on,
if it
so-
does. And I might even try to use the steering wheel. I never use the steering wheel, but here's the point cloud in 3D in perspective view, not orthogonal. And let me turn on my steering wheel. If you've got steering wheel, this is mostly a useless tool. I teach Revit, but it does let you do two things that are cool. It lets you look around, which now I can look down at where the surgery is happening. And I can also walk with it. I looked too far there. Let me look back up into the grandstand.
There's a little lag on our
There's a
end,
big
James.
lag.
I think it's
And you have your link turned on.
So inside of Revit, if you've got model elements, they show superimposed. You see some walls in the background, actually not even in this room. But you can have your link where it's turned off in your selection filter so that when you hover over the point cloud, it doesn't highlight every time. It'd drive you crazy if it did that. And then if you pinned the element, you can turn off your pin filter, and it really just shows there, but you're not actually clicking on or dragging it and getting it off of registration.
And I usually like to have ReCAP up on a second monitor if your computer can handle it, because ReCAP seems to me at least gives you a crisper image, a crisper
Well,
360-degree image.
If James would turn his link off in this view, that image would be crisper. The Revit link that's in there, James.
Okay, yeah, let me go to visibility graphics here. And also I've got a whole lot of floors on. In fact, I'll turn the exterior off too. So we're dealing just with the 12th floor now. Let me if this, oh, it runs much faster on my screen. I don't know if Zoom is lag or, yeah, the Zoom.
So at the link off, it is a clearer picture.
Yeah, it's
It's not
clearer.
perfect, but
No.
you can make out what you're seeing.
But in Revit is where you want to measure.
Mhm.
ReCAP, it gets close and it can be fairly accurate, but it's very easy to accidentally click on a plane that you don't mean to. So section and plan in Revit is where you want to measure the point cloud from.
Yeah, for determining wall locations, I like to go into a plan view. Now, I have made this one where we see all of the floor, but if I'm doing some work in here, what I like to do is change my view range in the floor plan view. And I like to, instead of cutting up at 15 feet here, we're going to bring up our bottom. And so we'll make this 14 foot 8. So we'll look at a 4-inch slice through here. And if this is the elevation of the walls that I'm wanting to place, now I'm just looking at 4 inches worth of dots. And man, look how many dots there are just in 4 vertical inches. I might even narrow that down to be a thinner slice if I just like the clarity.
But it's a lot easier to see a clean line. You're not looking at the base profile. You're not looking at other things below you.
Yeah, that's thrown me off before. I have modeled to a baseboard or to a cove molding or something that was stepping out from the wall.
But it's good to know that those things exist if you have to model those in too.
So here's a 1-inch slice. And just even in 1 inch, we've got enough dots that, you know, you want to have enough that you know what you're looking at, but you want a nice crisp edge for locating things.
Yeah. Just enough dots, not so many dots that you now have a file that's too big to work with.
Right, so this project, we're actually starting in modeling from the point cloud, and that's most common, but whenever I did a point cloud for my house, I actually already had a model and I corrected it to the point cloud. So if you've already begun a project and you need to make correction to it, then you might still do pretty much the similar workflow. You might create reference planes on that outer envelope and just use the align tool, and it will assume the angle, the slightly off angle that is. You do want to be careful when you're working inside of Revit that you pay attention if you ever get the error that, that the element is slightly off axis and may cause inaccuracies. If you get 0.2 degrees or less off of orthogonal, Revit will typically issue that warning to you. And if you model a wall at that slightly off axis angle, it might actually refuse to be a host for doors or windows. I've seen that happen. So we typically try to treat it as orthogonal if it's that close. And only if it's, you know, more than 0.2 degrees off of orthogonal are we going to go ahead and model it precisely where it is. we have any other questions coming in?
None just yet. Any other questions about ReCAP or the Revit side? I'll watch the window just here for just a moment.
Okay, sure, yeah.
If you would, James, while we're waiting on questions to come in, pan out and show them generally that you can see the entire floor plan without modeling done across this entire floor.
Okay.
Just the 12th floor works fine.
Yeah, at this height, this 1-inch slice
Yeah,
through
you'll have
the
to bring it
entire
down.
building.
You'll have to bring it in down a little bit. But
Yeah. Sorry, it's still wanting to zoom out. I think I've still got lots of the floor scans loaded, not just the 12.
yes, you have several.
Can't wait to get that new computer in my hands. So I've actually sat through a few other talks with other people presenting about reality capture, and inevitably that question comes up, and I'll go ahead and ask it for them. How do you get the size of it down so that your hardware can handle it? And what I've actually heard other people answering is that you probably just need better hardware.
Yeah.
It takes up a lot of space.
So bring that to your boss and see how things go.
Graphics card.
Well, just to add to that, the workflow we developed is to get these as small as possible to use on a decent machine.
That can be turned off and on in Revit in pieces as needed by the particular project.
And this is a very large project, and better hardware would be better.
So have you guys worked with a point cloud inside of AutoCAD? I know we typically don't do that. We do have a question related to that.
Is it AutoCAD or AutoCAD Lite?
AutoCAD LT. Actually, that won't do it because it's two-dimensional only.
Right.
AutoCAD, the full AutoCAD, is my understanding, it actually will handle the point cloud.
It will.
I'm unaware of how you handle the range of what you're looking at.
First of all, it definitely has to be leveled to the plane that you want to look at inside of AutoCAD.
Mm-hmm.
But yes, AutoCAD from 2016 on has a way to insert a point cloud into it.
You know if LT can do point clouds?
LT is 2D only, so it won't.
Now I know that I've got all of the scans turned on because my computer is acting like it wants to die right now. If it does, we might have you kick back over to ReCAP and show something else.
Hence why we wanted to break it up.
Sure.
That's exactly the reason why we wanted to break up the files. Yeah.
And you should set up view templates. We're just now getting started in this. We haven't created our view templates to turn that stuff on and off automatically. We did set it up to where each view is set to existing phase, so that as we model this, it just comes in already as existing construction for when we finally hand off the model here. So let me jump in visibility graphics while it's taking a breath. Yeah, I've got every floor turned on.
Someone does have a question about specific computer components that might be needed to dealing with point clouds. It's a very broad question. It's absolutely depends on the project itself.
It does.
What do we have on your bin box right there? Do you know any specs about it? This thing's a monster that Jeff has.
Oh yeah.
Everyone would like his computer, but it's pretty big.
Right. Well, it actually just the working drive on it, what normally is a C drive, mine's an R drive, has 8 terabytes of space. It has 128 gigs of RAM, and it has a video card that most gamers would envy. So,
but James has just what we would consider kind of a mid to
I've got a happy gamer rig, but not a
right.
I'm the world's richest gamer rig.
Right.
But when it comes to dealing with the point clouds separated into floors at even a footprint this big, because this is still a giant floor footprint, even when it's separated into floors, he's still doing okay. I mean, he's able to do what he needs to do.
And he would have done better if he'd remembered to turn all those scans off.
You'll just beat me while I'm down while we're being recorded here. So I've got it limited now to 12th floor plus exterior scans. So we're seeing the inside and outside coursing of it. Just a 1-inch slice through the building, and this floor needs to be redone because it actually rounds out there on the 12th floor.
Emily asks, can you assign the point clouds to a dedicated work set so that you could sort of control your visibility by work sets? And I believe the answer to that is yes.
Yeah, you can do that.
You can do it by a work set for the whole thing, or a work set for each individual floor too. The good thing about that is you can actually choose to not load the work set at all. You know, when you're opening a project,
you can have them loaded by accident too. I mean, it's
but these are linked in, so they can be unlinked later at any time.
Mm-hmm.
This
Yeah,
one's
so Dave is pointing out that you do need more of a computer for actually processing scans than you do for just using Revit. So if I'm
That is
the
correct.
architect, the design architect, and I'm just interested in working on this thing in Revit, then I don't have to have a bin box Raptor with 128 gigs of
Yeah.
RAM.
you want a graphics card and you want
Mhm.
some decent space to be able
Yeah.
to deal with the
The
files that you
one
get
thing,
from.
and usually it's very easily done on most computers, is increase the RAM to the maximum it will take and make sure that it's good RAM.
We're bumping up on our hour right now.
Oh, I just got
Oh.
it corrected
Yeah.
where I wanted to now.
Right.
So now we're looking
Okay.
at a 1 foot slice. We're looking at 3 feet up to 4 feet. And I get a little bit of a hairiness to the lines, but I definitely know that that's wall that I'm looking at, all through
Yeah,
this.
that's exactly. You can see the floor plan and you haven't modeled the thing.
Mhm. And this must be something on the slope here because I'm seeing kind of a wide edge there.
That edge there, that was actually a bunch of stuff stacked up in that room.
We got the start of our stairs. How awesome would it be to try to create stairs from manually taking measurements? That would be fun.
One thing we did notice on this project too, after Jeff had done his scans and we brought it into Revit, is that we mentioned this earlier, there was some settlement in the building. And once you are in Revit and you cut a section through the ends of the buildings, you can actually see that very, very well.
Let me see if we've got
A lot easier than in ReCAP itself.
We have a section that
Yeah.
may have been saved out.
Michael created it.
There's a question from James, is error correcting RAM desirable? I don't know that
I
term.
don't know the answer to that question, but we will keep it and see if we can get an answer. I don't see it, James.
Yeah, I don't see it either.
It's in the other project.
I created one for a typical window bay where I took a look at the windows, maybe a little bit early to show that. We've got a few more. Well, we're bumping up on the hour here. I'll show how you could actually choose the heights and how you could. Next time we'll get into setting stacked walls so that you can have that condition of exactly what it's doing in each window bay. Did you guys have any more questions about at this early stage working inside of Revit, or actually we just got time for the recap? It looks like.
Well, I just put the screen up. Feel free to keep talking.
Okay.
But just in review, we've talked about this for an hour. We've had a lot of great questions from everybody. But just as a recap, just before we leave today, reality capture hands down beats traditional measuring. The amounts of data that you can collect as quick as you can with laser scanning is going to give you the most accurate representation of your as-built conditions.
I would say even on a small project.
Yeah.
Now, I'm not saying that Jeff doesn't have to spend time registering stuff together, but I mean, if it's been a couple of years since you got a quote on laser scanning, I mean, with the way that the software can help you register it together now, in some cases you're paying for somebody's time to be out on site plus just a little bit of time registering it together. So even on a small project, it's still going to be taking photographs and counting bricks.
Right.
Right. And so that last one we did in Memphis, you and Quentin went out. You were only there a little over a day in time.
Yes.
Scanning it, and what was that?
So we scanned had 4 floors in a basement, large warehouse, and just 2 of us operating BLKs were able to scan that, I want to say in about 12 hours, somewhere in there.
Well, I know it only took me 7 hours to register it, so.
Yeah. And so that's actually, even though it's a 5-story building, it's actually not much man hours to pay for, if you're hiring some people to go out on site to do that.
Yeah, and so plan your scanning attack from the beginning.
Right.
In this particular project, that was stair 6. It connected the most floors of anything out there that was available. Your project may be different, but just plan to scan from the places that will allow you to overlap your data points enough where you can stitch this thing together. For large projects like this one, be just as concerned with over scanning as under scanning.
Over scanning, that sounds good.
Yeah, you definitely need enough points to deal with them and to have the information you need in Revit, but you don't need every single millimeter with a point on it, right? To be able to get the point across. your computer is gonna thank you if you can keep the file size down a little bit. So just be cautious. Jeff mentioned that for very small rooms on low, scanning on low gave him just as much accurate data as
basically
on
any
high.
room that's under 12 by 12.
Low
Low
was,
is fine.
yeah.
And even if it's larger than that, you can do multiple scans in one room.
If you've got a small room that's a complicated mechanical space, you juice that up.
Oh yeah, bring it on up, get good points, because the more points, if it's just peeking through a little hole and you're needing that data that's over
Yeah,
there.
you'd rather it send 8 laser shots through that hole.
Yeah. So
Yeah,
you
instead of
change
one.
change depending on the room you're in, not just setting it and forgetting it
Right,
across
it
the whole
depends the
project.
purpose of the scan.
Right.
The architectural scan, but needing some of that data where the pipes and stuff are for the sprinkler
Right.
system, low is fine. Somebody that needs to be able to see the numbers on a valve in a mechanical room, you need a higher resolution scan.
Now, Jeff, I know the types of buildings you're mostly doing. You're doing a whole lot of historical buildings, warehouses, a bunch of large industrial too. Who are the customers that are first latching on the obvious value of it?
The customers are.
Now, you can't mention names, but like
Yeah,
the
that's
types
really.
of
I'm sitting there
construction.
thinking about my.
Jeff's like, I got NDAs.
Yeah, I can't talk about that.
Right.
Yeah.
Large grocery stores. I know.
Large grocery stores. Yeah, they're getting into that. Some of the big box stores are doing it for a couple of reasons: verification of what they own, knowing how many square feet they have out there. Is the building laid out for the best display of the groceries, this, that, and the other thing, plus all the freezer stuff.
What's the smallest project you've done where the architect or the owner still saw value in having a laser scan done?
Okay, on this one I can't talk about. The Archimania office building we did in Memphis. It was not much over 9,000 square feet. We scanned it in a couple of days. And he was able to go in and get that. I don't remember what he paid for it, but in just a few days after that, they already had their shell all modeled. It was already gutted out, but he saw the value in it, because if they'd gone out and measured by hand and brought all that information back, there's no way they could have modeled it in that period of time.
Now, on the large grocery store, I can answer this one because I was part of a crew that went out there. We had 3 guys, and we were able to scan an entire large Texas-based grocer type of store that you've probably been in something like that. That's as close as I'm getting.
Okay.
We could scan that whole thing in one day. With 3 pieces of equipment and 1 person registering that after hours.
And that's every unique space in the building, the exterior and the roof with all the mechanical on top.
Oh, I know, it was hot.
Yeah. Well, the one day, I mean.
Yeah, in one day.
Yeah.
What we always try to keep in mind is who's going to actually use the data that we're collecting. Is it going to be an architect making a model from it? Is it going to just go in a file somewhere with the city where they want to just see the sort of 3D images in ReCAP? And if we need to split that file into smaller pieces to allow it to be easier, digestible within Revit, we will do that.
The mechanical guys are really finding a great value in this in existing space that they're trying to route new improvements through. Whether it be pipe, new piece of equipment, everything, they can see everything. It links right into Revit. They're able to know what they have to move. All of their pre-work can be done before they go in to even try to do that.
Check clearances that are existing.
So your shutdowns, less shutdown time. They're completing projects in half or better the time on the construction side of it. But even better than that, because they have good data in their mechanical rooms, their design side of it is going 60 to 80% faster.
And I've been involved in projects, particularly with structural, where when there's existing conditions, whether structural or building systems, where the engineer just doesn't want to touch it. If it's structural, they're like, well, I'm just going to sister steel next to that. I can't trust that existing steel. But here, you can actually determine the profile of the steel.
Not the weight.
Not the weight, but the profile of the steel from the scan. And with mechanical, you got photography mixed with that. So you can actually see the direction of flow arrows that are on pipes. You can see where exactly the conduits run. If it's electrical, you can have photography right in front of panel boards.
Yeah, and if you slice it up right, you can see all that inside of Revit.
Yeah.
And just to give you, for instance, worked with a mechanical engineering firm in Little Rock that did a mechanical room. in a hospital in Little Rock that they've been trying to model for years, and they accomplished the whole room in 6 weeks, going from point cloud into the Revit and modeled that. And they said that we never would have been able to accomplish it. Now every job that they starts with a scan and goes before it goes to design.
All right. Well, if do we
Cutting
have
us off, Mandy.
well, we don't have to be cut off. If anyone wants to jump back and recap, we are here for you. But I do want to let everyone know that we thank you for joining us today. And if there are any more questions, now's the time to ask them.
I like that we've got a bit of an IT crowd as part of this group. You know, if you guys are looking at the value of this group, I know you guys don't know each other, but I can tell already just from the computer questions and answers happening that there's some people that know a thing or two.
They know they need the right computer system to handle this amount of data.
Yeah, just
ask
tell
those questions.
them, ask Jeff, what computer do I tell my boss I need?
Yeah. We'll take that offline and deal with that on an individual case-by-case scenario.
Jeff answers how much money you got.
Yeah. And we do want to mention that our team, our A team here at ATG is currently actually modeling this particular charity building. We were also hired not just to collect the point cloud.
I'm talking about it right now.
I know, right? They get it, right? But we also are going to kind of do a follow-up Charity Hospital Part 2 Universal User Group, where we're going to get into some of the issues modeling in Revit, the things that we found, the things that we had issues with. We'll do a deep dive with sort of lessons learned on this particular project. It's big. We have a lot of randomly sloping floors that probably were built flat at one time, and we have a lot to dig into. So look for a second Part 2 of this user group session to come out sometime first part of November, more than likely. At least by the end of the year is our goal. And another request for any of those who are still on the line is we would love topics from you. We can come up with all kinds of topics on our own.
I was supposed to send out a survey.
Oh,
Sorry.
I don't even know where that is. But if you have a topic idea, please email our marketing team. This could be for a future webinar or also a user group format like this where you can ask questions and be a little bit more engaged. We'd love you to drive some of that process. Some of those ideas.
On the poll is it says I'm logged in from another device. See if you can do it.
How do I start a poll?
In the bottom of it where it says share your screen, see if you see a button that says polls.
I do.
Let Jeff do
See
it.
if you can fire it off.
There we go.
Boom.
All right, so we have just a very short polling session for those of you still with us. If you don't mind and still have some time left in your day, please take a moment to answer some of these questions. And with that, once you're done with polling, I want to thank everyone for joining us today. This has been interesting. We haven't done it in this format before. I am glad that Zoom held on and no big technical issues happened on our end. Thanks to everyone who joined us.
I didn't see the poll.
It's coming.
It's coming in right now.
And we will take some of your polling answers into account when we schedule the next user group. So those of you who really like this time, if
The next one's gonna be in November, isn't it?
Yeah, if the after hours in some areas is working best, we find this is 3:30 our time. We're kind of in the afternoon on the West Coast, so this seems to be a good middle. But we'll take any and all responses into account when you start scheduling these next user group meetings.
Any questions we didn't get, we will send a follow-up email, I think. We've got it as part of the log here.
Yep. Well, we'll let the poll continue to run for a little while, but we'll go ahead and sign off on our end and send a big thank you again for everyone joining us live.